Hi, hello, welcome to Vision for Developed India channel. So, in last session, we done that electrolysis. Today, on that electrolytic cell. In that electrolytic cell, how conductivity, how resistance, or basically these are the terms resistance, resistivity, conductance. These are the terms which you learn in physics only, but there we'll discuss resistance. In the physics itself, what you learn about resistance, the property of a material to oppose the flow of electricity is called resistance. Like that you learn. But here in electrolytic cell, uh, how in electrolytic cell about resistance, conductivity, and molar conductivity that we are going to learn. First of all, what is electrolytic cell? Electrolytic cell means a beaker containing an electrolyte in which two platinum rods dipped. This is the electrolytic cell. So what is electrolytic cell? Generally definition, you know what is electrolytic cell? The cell which converts electrical energy into chemical energy is called electrolytic cell. So in electrolytic cell, a single beaker containing two platinum rods connected to the battery, which is a source of electricity. Now this electricity entered into this one through electrode. Electricity enter into this electrolyte, anything, whatever it may be, molten NaCl or anything. When electricity allowed into this one through this platinum rod, when electricity entered through this electrode into this molten NaCl or electrolyte, generally you learn that in resistance, what is resistance? The property of a material or a substance to oppose the flow of electricity is called resistance. Now, here you observe every every substance will allow electricity. At the same time, it has some opposing tendency to allow that electricity. Suppose here, now in electrolytic cell, resistance in electrolytic cell, if you observe, if the area of this platinum rod is more, electricity easily entered. Electricity easily entered means resistance is less. If area of the electrode is more, then resistance is less. So, area is more, resistance is less, means inversely proportional. So, we are going to observe the resistance of electrode and electrolytic solution. So R is inversely proportional to area of the electrodes. Whenever electricity entered through this platinum rod into this electrolyte and it transfer from here to here. Now again, this solution if you take, electrolytic solution if you take, it allows electricity as well as it opposes that flow of electricity. So if the distance between the two electrodes is more, then the factors that oppose electricity is also more. If the distance between the two electrodes is more, then the resistance is also more. So resistance is directly proportional to the length between the two electrodes. Resistance is directly proportional to length between the two electrodes and inversely proportional to the area of cross section of electrodes. So actually what you learn physics, that is okay, but here in chemistry, electrolysis, in electrochemistry, we are going to observe the resistance in the electrolytic cell. So the resistance in the electrolytic cell is inversely proportional to the area of the electrodes and directly proportional to the length between the electrodes. Then R proportional to L by A. either capital A or small a, whatever you want you can take, either. So R is proportional to L by A. That implies if you remove that proportionality you will get a constant. What is that? Rho L by A. Here rho means specific resistance. R is resistance, here rho is specific resistance. Rho is a constant known as specific resistance. Now you observe, you look at here. So resistance, here the parameter is resistance. The resistance formula R equal to rho into L by A. Rho is nothing but a proportionality constant here. Rho is a proportionality constant known as what is that? Specific resistance. Specific resistance, another name is resistivity. Specific resistance, another name is resistivity. So you observe that once again, this is an electrolytic cell. When electricity entered into this cell, the resistance is inversely proportional to area of these electrodes and directly proportional to length between the two electrodes. Therefore, R is proportional to L by A. That implies R equal to rho into L by A. I am going to rub this one. So, resistance. The units for resistance is ohm. The units for resistance is ohm. Now you look here. Resistance R equal to rho into L by A. The resistance R equal to rho into L by A. So resistance R equal to rho into L by A. The units for resistance is ohm. See, you know that units, for example, length units centimeters or meters. Just like that. See, that centimeter is CS unit, meter is SI unit. Just like that, ohm is the SI unit of resistance. Suppose you take this one. So this we derived from the electrolytic cell. Now if you take rho equal to, you bring this one this side, R into A by L. Rho equal to R into A by L. If A equal to 1, L equal to 1, then rho equal to R. So rho is nothing but R. Specific resistance is nothing but resistance when it is when will, yes, when A equal to 1 and L equal to 1. So what is specific resistance? The resistance of an electrolytic solution or the resistance offered by an electrolytic solution when the length between the two electrodes and area of cross section of electrodes becomes unity. So the resistance in the electrolytic cell when the length between the two electrodes and area of the electrodes becomes unity, then specific resistance is nothing but resistance. So we observe here specific resistance means rho, another name is resistivity. So rho equal to R into A by L. Rho equal to R into A by L. Anything you use, either capital letter or small letter, nothing wrong. So rho equal to R into A by L. Now units, you know very well that units for R is ohm. Units for R is ohm. And A means meter square. A means meter square. Area means area. Area means length into length. So meter into meter, meter square by meter. So meter one cancel, then ohm meter. So ohm meter. So the units for resistivity is ohm meter. Or sometimes in the options, suppose they will ask in the objective like this, which of the following is the unit for specific resistance or resistivity? Then in the option you check it. If it is ohm meter, then it is okay. Maybe sometimes they will give like this, ohm centimeter. Area means centimeter square by centimeter. So the units for resistivity is ohm centimeter or ohm meter. Now, next one you observe conductance. Resistance and conductivity. Resistance and conductance. Resistance means the property of a body to oppose the flow of electricity. or the property of a substance or the property of a material to oppose the flow of electricity is called resistance, whereas conductance means opposite to that. The property of a material to allow the electricity, to allow the flow of electricity is called conductance. So conductance and resistance are reverse, means inversely proportional. So or see that reciprocal, see the sorry, conductance is the reciprocal of resistance. So conductance, see, conductance is the reciprocal of resistance, so C equal to 1 by R. Conductance is the reciprocal of resistance, so C equal to 1 by R. You substitute this R value in this equation, C equal to 1 by R. So it numerator, this come into denominator, and here denominator will come into numerator. So 1 by rho into A by L. So conductance, or otherwise you can call it as G. Conductance you can represent as C or G. Generally in physics you will represent C, but here we will take that as G. Of course, both are same only, either C or G. So conductance G equal to, conductance G equal to, what is the formula? 1 by rho into A by L. 1 by rho into A by L. So conductance. Now here you observe G equal to 1 by rho into A by L. 1 by rho. 1 by rho means what? Resistivity. Rho means resistivity. The reciprocal of resistivity is called conductivity. 1 by rho. Rho means resistivity. 1 by rho means reciprocal of resistivity. The reciprocal of resistivity is called conductivity or specific conductance. So in place of 1 by rho, you can write K. So K into A by L. K means what? Reciprocal of resistivity. Reciprocal of resistivity. The reciprocal of resistivity is called conductivity. Conductivity. See that conductance is different, conductivity is different. Conductance means G, and conductivity means the reciprocal of resistivity. Resistivity. Conductance means the reciprocal of, conductance means reciprocal of resistance. Conductance means reciprocal of resistance, and conductivity means reciprocal of specific resistance, or specific resistance another name is resistivity. So G equal to K into A by L. Now K equal to, you bring this side, G into L by A. K equal to G into L by A. K means what? Conductivity. K equal to G into L by A. So you observe here. Now you check it one by one. Conductance. Conductance means 1 by R. What is the unit for resistance? Unit is ohm. 1 by R. 1 by ohm. You bring upside ohm inverse. So conductance unit is ohm inverse, or otherwise mho, or otherwise Siemens. So the units for conductance is ohm inverse, mho, or Siemens. Siemens. That's all. Now you observe this one. K. K, conductivity, K equal to G into L by A. G means conductance. G means conductance. Now you observe that units. Units you observe. Units you observe. G equal to, K equal to, units for conductivity, K equal to G into L by A. G into L by. G means what? G means conductance. What is the unit for conductance? Siemens. Siemens. So Siemens. Siemens. Now L means meter. A means meter square. Meter by meter square. Then what you will get? Siemens meter inverse. Siemens meter inverse, or Siemens centimeter inverse. This is the unit for conductivity. Now next one, molar conductivity. Next one, simply here I am going to give you molar conductivity formula. Just molar conductivity formula only. Molar conductivity is equal to lambda m. Lambda m, or sometimes in the books itself they can represent like that also. Anyway, you just pronunciation you call it as lambda m. Lambda m. Molar conductivity. Molar conductivity. So molar conductivity is equal to K into 1000 by M, means molarity. K into 1000 by M, molarity. Better you learn here only formula, molar conductivity, lambda m, and further problems in the whenever we are going to discuss problems like that one by one, you will get clarity. So molar conductivity, lambda m equal to K into 1000 by molarity. So units are Siemens meter square mole inverse. Siemens meter square mole inverse. This is the molar conductivity. Now actually here which you have to mainly concentrate. Generally suppose to want to, if we want to find body temperature, one equipment is required. With the help of equipment we can find the body temperature. What is that equipment? Thermometer. With the help of thermometer we can find body temperature. Just like that, to find resistance, equipment is there, and resistivity and conductance and specific conductance. So the specific conductance of a solution or resistance of a solution, to find all these there is some equipments. That means experimentally we can find these all parameters. Experimentally we can find. So always there is an equipment to find some properties, means so for what, how we call it as that experimental determination or experimental observation is possible. Now here mainly what you have to understand, molar conductivity, molar conductivity, molar conductivity, molar conductivity, molar conductivity, you observe molar conductivity. Okay, before, mainly the purpose or main point what you have to inject your mind in your mind is about one is that Kohlrausch law. What is Kohlrausch law? Before going to Kohlrausch law, first of all, what is a strong electrolyte and what is a weak electrolyte? You should have an idea. What is a strong electrolyte? For example, HCl. For example, HCl. Whenever you drop this HCl in water, anything you dropped in water, then it is called aqueous solution. Suppose 100 HCl molecules you dropped in water, then what you will get? 100 H plus and 100 Cl minus. See, suppose whenever 100 HCl molecules you dropped in water, then 100 H plus ions, 100 Cl minus ions you will get. That means the total HCl split up into ions. The substance which undergoes complete split upping means dissociation. The substance which undergoes complete dissociation is called strong electrolyte. Which does not undergo complete dissociation is called weak electrolyte. For example, if you take CH3COOH, which is a weak acid, whenever if you take this one CH3COOH, whenever you take this one acetic acid, you dropped in water. Suppose 100 acetic acid molecules you dropped in water, then you didn't get that 100 acetate ions and 100 H plus ions. So though you dropped 100 acetic acid molecules in water, 100 acetic acid molecules not dissociated into ions, only 2 or 1 will dissociated. Remaining, suppose 100 initial and so 2 dissociated, then 98 2. So undissociated, although you dropped 100 acetic acid molecules in water, all are not going to be dissociated. Out of 100, only 2, 3 or 1 molecule like that only will dissociated. So these are dissociated ions, and here some amount of acetic acid is left, that is called undissociated acetic acid. Then there exists an equilibrium between undissociated acetic acid and dissociated ions. So this is called, anyhow, undissociated acetic acid and dissociated ions, there exists an equilibrium. Anyhow, the topic is what is strong electrolyte and weak electrolyte. Which does not undergo complete ionization is called weak electrolyte. Which does not undergo complete dissociation is called weak electrolyte. Okay, actually, if you are going to learn some Kohlraasch law, before that some concept you require. What is strong electrolyte? What is weak electrolyte? Strong electrolyte means which undergoes complete ionization is called strong electrolyte. Weak electrolyte means which does not undergo complete ionization is called weak electrolyte. Now again here, dilutes, here generally infinite dilution and dilution. Generally, suppose, what is infinite dilution? What is infinite? And one more terms you require, infinite dilution. Suppose you take 1 gram of sugar and you dropped that 1 gram of sugar in water, 1 glass water. So, or 1 spoon sugar in 1 glass water. So that water is solvent, sugar is solute. So finally solute plus solvent is equal to solution. Whenever you taste that, you feel that some sweetness. So that is sugar solution. So the amount of sugar present in that the amount of sugar present in that water or solution, of course that solution topic is not required right now. So that is called concentration. The amount of solute present in the solution is called concentration. Okay. Suppose that same 1 spoon of sugar you dissolve in 1 bucket water. Then that 1 bucket water means that solvent quantity is very high, highly diluted. That is called infinite dilution. What is infinite dilution? If the quantity of solvent is very high when compared to the quantity of solute, then it is called infinite dilution. Then it is called infinite dilution. See what I am saying, to understand that Kohlraasch law, you should have an idea strong electrolyte and weak electrolyte. Okay, strong electrolyte and weak electrolyte, and then infinite dilution. So before that I said you that anything, any parameter and any property we can find experimentally. So experimentally, if you observe that experimentally it is possible to find that body temperature by using the equipment thermometer. Now here molar conductivity, the molar conductivity of strong electrolytes, the molar conductivity of strong electrolytes can be determined by the instrument, even at infinite dilution. The molar conductivity of strong electrolytes can be determined even at infinite dilution by using that instrument. So the molar conductivity, here specifically you move to this one, molar conductivity can be determined by using an instrument of strong electrolytes either in low concentration or infinite, either in low concentration or high concentration. Low concentration means infinite dilution. At any concentration, even at infinite dilution, it is possible to find the molar conductivity of a solution containing strong electrolyte. Suppose weak electrolyte you take. Suppose weak electrolyte. Now only I discussed weak electrolyte means which undergoes partial ionization. So it is impossible to determine the molar conductivity of weak electrolyte at infinite dilution. The molar conductivity at infinite dilution is denoted as lambda naught. Lambda naught. The molar conductivity at infinite dilution is denoted as lambda naught. So, which is not possible experimentally. Which is not possible experimentally. So, experimentally we cannot find the molar conductivity of a weak electrolyte at infinite dilution. At infinite dilution. See that conductivity is because of ions. So, whenever you drop this weak electrolyte in that water, it can split up into ions. So, that conductivity means molar conductivity at of weak electrolyte, when the water quantity is very very high, it is not possible even by using experiment. So, which we not able to find experimentally, in that cases, sometimes we can find with the mathematical approach, by mathematical approach. So that mathematical approach to find that molar conductivity of a weak electrolyte at infinite dilution was given by the scientist Kohlraasch. The mathematical approach to find the molar conductivity of a weak electrolyte at infinite dilution by using mathematical approach was given by the scientist Kohlraasch. Now, what he said that we will discuss. See, what is weak electrolyte? For example, CH3COOH is a weak electrolyte. Suppose this one, lambda naught CH3COOH. The molar conductivity of a weak electrolyte at infinite dilution we cannot find by using any instrument or experimentally we cannot find, but which can find the molar conductivity at infinite dilution is also called as limiting molar conductivity. Limiting molar conductivity. Limiting molar conductivity. The molar conductivity of an electrolyte at infinite dilution is called limiting molar conductivity. See that limiting molar conductivity of a weak electrolyte cannot be determined experimentally. Cannot be determined experimentally. Cannot be determined experimentally. So cannot be determined experimentally. In that case, Kohlraasch proposed a law known as Kohlraasch law. Kohlraasch proposed a law known as Kohlraasch law. What he proposed that Kohlraasch law. What he said that the molar conductivity of a weak electrolyte at infinite dilution. See the molar conductivity of a weak electrolyte at infinite dilution. Molar conductivity at infinite dilution, in short form we will call it as limiting molar conductivity. So what he said that the limiting molar conductivity of a weak electrolyte, the limiting molar conductivity of a weak electrolyte at infinite dilution is equal to the limiting molar conductivity of a weak electrolyte at infinite dilution is equal to the molar conductivity of cation and anion. Molar conductivity of cation and anion. The molar conductivity of a weak electrolyte is equal to the molar conductivity of cation and anion. Suppose 2x equal to 5. Generally assume like that. 2x equal to 5. Now 5 plus 3 minus 3. We can write like this also. 2x equal to 5. Assume like that. See, this is also equal to this one. If 2x equal to 5, Then 2x equal to 5 plus 3 minus 3. Nothing wrong, both are same. Nothing wrong here, both are same. So the limiting molar conductivity of a weak electrolyte, is equal to the sum of limiting molar conductivity of cation and anion. Sum of limiting molar conductivity of cation and anion. When you split that or combinedly, so what is that? When you split that ions or combination, both are equal, like that he said. Now only observe that 2x equal to 5. We can write this 2x, if 2x equal to 5, 2x equal to 5 plus 3 minus 3, we can write like this also, nothing wrong, both are same. Now you observe here, suppose I am going to write like this. This is the statement given by the scientist Kohlraasch. Now I am going to write this one like this. Lambda naught CH3COO minus plus lambda naught H plus. I am going to the same state, writing this one like this. Lambda naught CH3COOH is equal to lambda naught CH3COO minus plus lambda naught H plus lambda naught Na plus minus lambda naught Na plus. I added and again plus lambda naught Cl minus lambda naught Cl minus. Just one salt I added. One salt. Salt is a strong electrolyte. Keep it in mind. This is the Kohlraasch law. What he said, that the molar conductivity of a weak electrolyte at infinite dilution, or otherwise limiting molar conductivity of a weak electrolyte or any electrolyte at infinite dilution, is equal to the sum of the limiting molar conductivity of cation, positive ion, and anion. Now I am going to add a strong electrolyte, addition, subtraction, like that 2x equal to 5 and 2x equal to 5 plus 3 minus 3, both are same, like this. I added Na plus and subtracted, added and subtracted. Now what he said, that either combinationally you find or individually you find, nothing wrong. He said like that. Now to this one, lambda naught CH3COO minus, I am going to add this one. Then what you will get? Lambda naught CH3COO Na plus. So I am going to add this one finished. Now this one, lambda naught H plus and lambda naught Cl minus. So then what you will get? Lambda naught HCl minus here minus lambda naught NaCl. Now in this process you observe, see, because of that statement, what is the benefit we got? That beauty you try to understand. Because of that statement, what is the statement given by Kohlraasch? Limiting molar conductivity of an electrolyte is equal to the sum of limiting molar conductivity of cation and anion. Sum means addition. Because of that statement, what the benefit we got, that you try to understand. So that why Kohlraasch why we are remembering that Kohlraasch. So what I am saying, our aim is to find limiting molar conductivity of a weak electrolyte, which is not possible by the experiment. Okay, by the experiment which is possible, limiting molar conductivity, it is possible to find the limiting molar conductivity of strong electrolytes. So we cannot determine the limiting molar conductivity of weak electrolyte. But because of this statement, the limiting molar conductivity of acetic acid is equal to the sum of limiting molar conductivity of CH3COO sodium acetate, which is a salt, plus limiting molar conductivity of HCl, which is an acid, strong electrolyte. Now NaCl strong electrolyte. So these are all strong electrolytes. These three we can determine. The limiting molar conductivities of strong electrolytes can be determined experimentally, but which is not possible to find experimentally limiting molar conductivity of weak electrolytes. So the statement, by using the Kohlrausch law, by using the statement of Kohlrausch, that we can derive like this. So the mathematical approach here is helpful. Mathematical, what is the mathematics? What is the mathematical equation? If two things, if anything is separated by equal to less than, if two things separated by equal to less than, greater than, like this, plus, negative, minus, these are all mathematical approach. So the mathematical approach is useful to find the limiting molar conductivity of weak electrolyte. So that is the benefit of Kohlrausch law. So though we are not able to find the limiting molar conductivity of any weak electrolyte experimentally, by like this we can, in this way if we write, and experimentally they will give this one, that one. So by substituting this, finally you will find this one. Suppose I am going to give you one problem. Suppose I am going to write one problem here, lambda naught. One problem I am going to write. Suppose a problem, lambda naught for NaCl. Lambda naught for NaCl. The problem is lambda naught for NaCl, HCl, and lambda naught for NaCl, HCl, and sodium acetate R. The limiting molar conductivity of NaCl, HCl, and sodium acetate are 126.4, 425.9 and 425.9 and 91.00 Siemens centimeter square mole inverse. So the problem is the limiting molar conductivity of NaCl, HCl, and sodium acetate are Siemens meter square mole inverse respectively. Then calculate lambda naught for CH3COOH. Lambda naught CH3COOH. See what is given? Lambda naught for NaCl, HCl, and CH3CONA. These are the given things respectively. Then calculate. So in first PU or in intermediate first year, you learn that which is a strong electrolyte, which is weak electrolyte, which is strong electrolyte, which can undergo complete ionization or dissociation, is called strong electrolyte. Here these three are strong electrolytes. Being strong electrolytes, we can find the limiting molar conductivity with the experiment. So these are the experimental values of these strong electrolytes given. So now what you have to find? Lambda naught for CH3COH. By using experiment we cannot find this one. By using experiment, lambda naught for CH3COH we cannot find. That's why what Kohlrausch said that. The limiting molar conductivity of a weak electrolyte is equal to the sum of the limiting molar conductivity of cation and anion. Here this is a cation and this is negative means anion and cation. So now what I done? I added this Na plus and addition, subtraction, again addition, subtraction. Finally I got this one. So what is given? CH3CONA, lambda naught CH3CONA, lambda naught HCl, and lambda naught NaCl is given. Then you substitute that. Now you substitute You substitute the values. See this one, lambda naught CH3 COOH is equal to lambda naught CH3 COONA. This one, this one, this one. So lambda naught CS respectively. So sodium acetate 91 plus. 91 plus. HCl. HCl you observe this one 425.9 minus NaCl this one 126.4. Now add these two and subtract that one. Then how much you will get? 390.5. 390.5 Siemens centimeter square mole inverse. Siemens centimeter square mole inverse. So mainly in this lesson today what we learn, you need to focus here Kohlrausch law. Experimentally, suppose a body temperature, to find body temperature, thermometer is there. The molar conductivity at given concentration and at infinite dilution. What is the given concentration? Here you try to understand. 1 spoon sugar dissolved in 1 glass water. Suppose that is called the concentration of sugar solution at means there that sugar quantity is more. Suppose 1 spoon sugar dissolved in 1 bucket water means, which is a very dilute solution. So dilute solution also say that it is a infinite dilution. If the quantity of solvent is very high when compared to the solute, then it is called infinite dilution. So any infinite diluted solution if you take, in that case for that solution to find molar conductivity, no equipment will support for weak electrolytes. Only for strong electrolytes, the molar conductivity of a strong electrolyte at infinite dilution can be determined experimentally, but the molar conductivity of a weak electrolyte at infinite dilution cannot be determined experimentally. So the molar conductivity at infinite dilution is also called as limiting molar conductivity. So the limiting molar conductivity of strong electrolytes at infinite dilution is possible to find experimentally, but weak electrolytes not possible. So Kohlrausch statement, what he said, that the limiting molar conductivity of a weak electrolyte is equal to the sum of the limiting molar conductivity of cation and anion. Now, so by using that addition subtraction, we will get some mathematical approach like this. So based on that, we substituted and finally we got the answer. So like that statement is useful. See, for that further continuation I will do in the next class. For continuation in next class tomorrow we'll do. Okay, thank you all. Bye.